Hey class, we are going to move on to lesson 6.2, parallelograms. As our warm-up for today, we have a few problems that are review over the last lesson. The first one states, what is the sum of the interior angles of a nonagon? How many sides does a nonagon have? 9, you're correct. Okay, so when we're talking about the sum of interior angles, remember to find that you take your number of sides minus 2 times 180 because you're essentially calculating how many triangles you can form with the diagonals. So in this case, since my number of sides is 9 in a nonagon, I would do 9 minus 2, which is 7, times 180 degrees. And we get, let me give myself some room, 1,260 degrees. So if you got that, good work. Number 2, what is the sum of the exterior angles of a hexagon? Now, as long as our polygon is convex and a hexagon has 6 sides, but that doesn't really matter in this case. The exterior angles are always going to total have a sum of 360 degrees as long as it's a convex polygon. So honestly, this little piece of information that was a hexagon didn't really matter as long as it was convex. 360, always. Okay. Number 3 says find the value of x in the figures below for 3 and 4. Okay, so in number 3, notice how they're giving you all interior angles. And in number 4, they're giving you all exterior angles. So I'm going to start with number 3 here. And I got to count up how many sides this polygon has. And it looks like it has 5 sides, pentagon. So to find what the sum of all those interior angles are going to be, I'm going to take 5 minus 2 times 180, which is 3 times 180, which is 540. Okay, now I have some known interior angle measures, such as 100, 103, but I have some unknowns. So I'm just going to total them and add them all up. I'm going to start with 100. Work my way clockwise. And that has to total 540. Okay. Combine your like terms there. You get 12x's. And you get 204 constant terms. So to solve this for x, minus the 204, divide by 12, you get x to be 28. Okay. Now I am going to have to make some room for my work here. So I'm going to give you a second to write that down. And just remember, folks, if I ever go too fast through one of these problems, you can always rewind it, pause it, do what you need, or go back to the answer key. I'm going to go ahead and erase my work here so I can tackle the next problem. You probably just only really need to erase that much. I'm just going to erase the whole thing not to confuse anyone. Okay. So the next one here, I'm given exterior angles, and this is a convex polygon. Remember, there can't just be any like caves in that make it concave. So convex polygons, the exterior angles always total how many degrees, folks? You betcha, 360. So let's go ahead and add those all up. So again, here I have some known ones like 41. Oh boy. My tablet's not really being my friend today. I think it's been a little overworked the last few days. 41. I have some unknown, such as x plus 13, 2x minus 14. Okay. All of these have to total 360 degrees. That was one of like our theorems we talked about in the last lesson. Okay, so again, just solve this equation, combine your variables, combine your constants, all your like terms, and solve for x. I got x to be 37. Okay. Now that we are all warmed up, let's start talking about parallelograms since we are in lesson 6.2. So the definition of a parallelogram is a quadrilateral, which means it has four sides, with both pairs of opposite sides parallel, hence the name parallelogram. So let's go ahead and draw one. I'm going to use my tool here since I don't have the best tools to actually draw one. So you guys just go ahead and use a straight edge if you have one. Do your best to draw something that looks like this, where the opposite sides are parallel. And let's make markings that these are parallel. Do you remember how to do that with arrows? So I'm going to say this side's parallel to this side. And my two horizontal sides, I'll use double arrows to mark that those are parallel. Okay, we better label this parallelogram. Let's call it A, B, C, D. So how we kind of like shorthand or write this parallelogram in math language, we would use a little mini parallelogram and use those four vertices, A, B, C, D. That's what we call that. Similar to what we do with triangles, but obviously instead of triangle shape, we're going to use a little mini parallelogram like that. It's a little bit better. Okay, there are 6 properties of parallelograms you need to know. 6 of them, and they're really important, and they're not too bad, and they make a lot of sense if you can understand the characteristics of a parallelogram, such as the opposite sides are parallel. Also true about the opposite sides, I'm on number 1 here, is that they are congruent, because the only way we could get these opposite sides to be parallel is by having congruent sides. If we were to make one side longer, one side shorter, those opposite sides would not stay parallel. So the only way we can do this is if each pair of sides that are opposite to each other are congruent, are the same length. So in my drawing here, look how I labeled it A, B, C, D. Please do the following. And let's just mark that side AB, which is opposite. And when I mean opposite, I mean they don't touch, just like those parallel sides are also congruent. AB would be congruent to CD. BC would be congruent to AD. Okay, that's a big one. That comes up a lot. Next one, I'm on number 2. Again, I'm going to call this A, B, C, D. Opposite angles are congruent. And this really comes from like alternate interior angles. We could break it down and look at a transverse and all that stuff, but we've kind of went through all of that, discovered all that in earlier chapters. So when I say opposite angles, such as like A and C, ones that don't touch each other, those are opposite angles, would be congruent. Again, this all stems from those 2 parallel sides, which is what makes it a parallelogram. C and D, opposite angles. Oh, I'm sorry, B and D. I think I said C. B and D would also be congruent. Okay, so we got lots of characteristics with the opposite sides. Opposite sides are congruent, and opposite angles are also congruent. Good to know. We have 4 more to go. Any 2 consecutive angles are supplementary. Okay, consecutive mean that they're like next to each other is a good way to think about it. So let's go ahead and again label this parallelogram ABCD. I'm doing that same order. So we said A and C were opposite angles. Now A and B, now I'm not going to mark them with congruent symbols, I'm just going to put dots. Those would be consecutive angles. They're right next to each other, so they would be supplementary. Do you guys remember how many degrees supplementary angles add up to? 180, you're correct. A and B, B and C would be supplementary because they are consecutive right next to each other. C and D are next to each other. Those would also be supplementary. And D and A would be supplementary. Again, that kind of stems from, like if I were to draw this, they have to total 180, and like these angles are congruent. So a lot of those kind of characteristics create that supplementary relationship. All right, halfway home. Next one, a diagonal will create two congruent triangles. Okay, we talked about diagonals before. Those are connecting two opposite vertices. So let's just say I do A to C. That means it's going to split this into two congruent triangles. So you can see I have this triangle here, ABC, would be congruent to this triangle, CDA. So let's write that. Now we could prove this, very quickly, very easily. Let me just finish writing my congruency statement here. Triangle ABC would be congruent to CDA. We know the opposite sides are congruent, and we know that diagonal is congruent to itself, so side 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 could be a reasoning for that statement, congruent statement. Okay, next thing. Ooh, I like this one. The diagonals, and again, all because these are parallel lines to each other that these special characteristics happen. The diagonals bisect each other. Remember what bisects means? It means split in half. So I'm going to call this like intersection point E. So that means it would bisect the line segment AC, meaning it would cross at its midpoint is another way to think of that. And it also bisects that other diagonal BD. So AE would be congruent to EC. And again, I apologize, guys. My handwriting on my tablet is not the best. I'm writing with my finger. BE would be congruent to ED. Okay, the diagonals bisect each other. That's pretty neat. Last one, this one's kind of fun too. If a parallelogram has one right angle, let me label this one again. A, B, C, D. So let's say angle B is my right angle. Then all the angles are right angles. Why? Well, A and B have to be supplementary, so they have to add to 180. And B and D are opposite angles. They're congruent. And again, picture this. If I have parallel sides here and a right angle, the only way that parallelogram could form would be if it were a rectangle. Lovely drawing, Miss Entrich. Okay, that's really our new stuff for today. We're just going to try some example problems now. So our first one here says, find x and y for parallelogram DEFG. Okay, so I look here, and this side says I have 4x minus 1, and the opposite side is 15. So we know opposite sides are congruent. So I'm going to set those equal to each other. Let's make that note. Opposite sides are congruent. It's one of our properties. Okay, so this turns into a nice, easy equation to solve. X is 4. Y is located up there as a measure of angle E. And I see its opposite angle, G, is 53 degrees. Another property is that opposite angles are congruent. So I set those equal to each other. No algebra needed here. Y has to also be 53. Why? Opposite angles are congruent. That's the nice thing about parallelograms. Because of those parallel sets of sides, lots of nice properties that are very easily to visualize and understand. Okay, next one. This one says find x for parallelogram WXYZ. Ooh, this time I'm not given a pair of opposite, let me do a different marking here, opposite angles. This time I'm given a pair of consecutive next to each other angles. We know consecutive angles are supplementary, meaning they have to add up to 180 degrees. Consecutive angles are subs. Okay, so to find x here, minus over that 42, you get 138. Divide by 2, you get x to be 69. Boom, bada bing. That's it. Let's try another one. Fun stuff. Find A and B for parallelogram WXZY. And I noticed that A and B are located on my diagonals. So I'm thinking back to all those characteristics with the diagonals, and I know, hey, I see both sets of diagonals here, and I know those bisect each other. So let me highlight this diagonal XY. That point S, where it intersects, is going to bisect it. So B minus 1 has to be the same as 9. Similarly, this diagonal, point S would bisect that as well. So 5A would have to be the same as 15. In our reasoning, diagonals, I'm just going to say diags, bisect each other. Meaning it splits it into two congruent pieces or passes through the midpoint, however you want to think about that. Okay, so to quickly solve these, we get B to be 10 and we get A to be 3. Just by dividing by 5, and for B, adding the 1 over. Nice, easy algebra for that one. Next one says find x for parallelogram FGHJ. So opposite sides here, and they're showing me they're parallel. That's what those arrows mean. Those arrows don't mean congruent, those mean parallel. But they did tell us it's parallelogram right here. We know opposite sides are not only parallel, but they're also congruent. So I'm going to set those equal to each other. Ooh, little distributive property here. I'm just going to make that note again. Opposite sides. This is notes for you. So when you're going to the quiz, you're looking back at your notes, you're like, why did I set those equal to each other? Oh yeah, opposite sides are congruent. Okay, let's solve. Ooh, variables on both sides. I'm going to move over this 4x over here to the 5x. Solve for x. We get x to be 6. Okay, only have a few more problems to go here. This one, there's no marking that the sides are parallel in my figure, but it says this is a parallelogram. So we know these are parallel. You don't have to do this, but we do know that. Okay, so it says find x, and now it looks like they're looking at angles. So you have to ask yourself, am I given opposite or consecutive angles here? In this case, these are consecutive. They're next to each other. Opposite would be in opposite corners. So consecutive angles are not congruent. They are supplementary. So these have to total 180. Sometimes people get those mixed up. When do I set them equal to each other? When do they total 180? Let me sum it up for you really easy. If the angles are opposite, set them equal to each other. If they're next to each other, consecutive, total them to 180, because consecutive angles are subs. Okay, you've probably already finished solving this by now with all my chatting, but I want to make sure we understand so when I come back, we can just pick up where we left off. Okay, so I got to here. Solving for x. I got x to be 7. Alrighty. Couple graphing problems left. Let's step it up a notch. These ones aren't bad. Don't freak out too much. Find the coordinates of the intersection of the diagonals of parallelogram LMNO with vertices L is at 1, 4. I'm going to plot as we go here. M is 7, 4. N is 6, 0. O is 0, 0. Okay. I think I'm going to use my line tool here to draw in. Oh, yeah. Let me try that again. My parallelogram. Okay. Now they want me to find the coordinates of the intersections of the diagonals. So let's go ahead and draw on my diagonals here. So that'd be from L to N. Diagonals are from opposite vertices and from O to M. So they want me to figure out where this point is. Now, this could be a lot of work if you're like, what the heck? Do I have to find the equations of those lines, set them equal to each other? No, 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 no. You don't need to do all that because we know diagonals bisect each other. That property of our parallelogram. Oh, also I should point out, we did know this was a parallelogram because you check out the slopes of the opposite set of sides. So for ON, for example, that's a horizontal line, a slope of 0. So is its opposite side. So those are parallel. And then if you count OL, rise over run, that's a slope of 1/4. And so does its opposite side, NM. So same slope means they're parallel. Okay, so these are parallel. All right, back to the diagonal idea. They bisect each other. So LN is going to get split in half. And OM is also going to get split in half. By that point where they intersect, I'm going to call it E. So really, an easy way to do this is just to find the midpoint of one of those line segments. So find the midpoint. You can do LN, whichever diagonal you want. LN or MO. I'm going to do LN. So midpoint formula. So we're finding E. Add the x coordinates. So I'm doing LN. So 1 plus 6. And then we got to calculate halfway. Add the y coordinates. 4 and 0. Find halfway. Divide that by 2. So we get 7 over 2. 4 over 2. So we get 3.5. 2 would be where those diagonals intersect each other because it's located at both diagonals' midpoints because the diagonals bisect each other. Okay, so don't make that problem harder than it is. Last one here, friends. 3 vertices of parallelogram WXYZ are given here. W is at -1, -3. Okay. X is at -3, 2. Oof. Try that again. Not much better. I don't know. And Z is at 4, -4. Okay, so I gotta find the other coordinate of the 4th vertice of this parallelogram. So let's go ahead and connect the sides we have right now. So from here to here, that would be, let me get my letters on these so I can talk to you in terms of letters. That'd be from W to Z. This one up here is X. And then from X to W, connect those points. Use a straight edge if you have one. So we have like a good idea of where Y should be. We're like, it looks like it should be, somewhere up here so that these sides are parallel. Now the reason why I plotted this on a coordinate plane is so we could calculate the exact slope here to figure out where Y is by making the sides essentially parallel. So let's figure out the slope from W to Z. So I look at a rise of 1, a run of 5, and you can jot this down over here if you want to. The slope would be negative 1/5. So I know from x to y, I'm going to have to make that opposite side the same slope. I have to make it parallel. So let's go ahead from, everybody put your pencil on point x. Let's do a slope of -1, so down 1 over 1, 2, 3, 4, 5. So you should have a point right there at 2, 1. Okay, now we're thinking this is where y is located, but let's make sure the other side would match up with it being parallel. So let's calculate the slope between x and w. So remember on a graph, guys, you can just kind of like make a right triangle with them and count your rise over run. So my rise here would be 2, run would be, or I'm sorry, rise would be 5, run would be 2. Oh no, oopsie, sorry. Tap something. Okay. This would be -5/2. So let's make sure that matches up from y to z. Do I go down 5/2? Yep, that matches up. So you can go ahead and draw in your parallelogram there. Oopsie. I want to draw a line. There we go. And what they really asked me were for the coordinates of y. So that would be at 2, 1. Okay, so maybe the only note I make there is we had to make the opposite sides parallel, which means they have the same slope. Same m, which means slope. That does not say 11. That says parallel. Parallel. Okay. I will see you guys tomorrow. You can get started on the 6-2 worksheet.